AND operation, right? Product means the logical AND operation and sum means the logical OR operation. So Boolean expression can be represented either in the sub form or in the PS form. Product form is the logical AND operation. Here we can see. So this is the product and sum. So it's the product of sum. So sum refers to the original OR operations and product refers to the AND operation. So in sum of product form, now we are talking about this sum of product SOP. In sum of product form, we will also have two different kinds of SOP. One is known as canonical SOP, another is known as non-canonical SOP form. The canonical SOP form is also known as normal SOP. So what is the difference, or what is the canonical or non-canonical SOP form? In case of canonical SOP form, in the product term, all the variables in the function will be available. If the function is containing three variables A, B, and C, so in each min term, all the variables A, B, and C will be present. Okay, that is known as canonical SOP, sum of product. So in case of non-canonical SOP form, each product term may or may not contain all the variables of the function. It may or may not contain all the variables in the function. That is known as non-canonical form. So this is very simple one. So in the canonical form, all the variables will be present, and in non-canonical form, all the product term, all the variables will not present. Okay. So all the variables that will be present, that means it can present in either true form or in complement form. True form means its original form A, B, C, and the complement form is A bar, B bar, C bar. So the variable can be present at either in true form or in its complementary form. Okay. So canonical SOP form, for example, this is a function of A, B, C of three variables. So we have, this is SOP, sum of product A, B, C plus A bar, B dot C bar plus A, B, C bar. So we have three min terms, we have three product terms. In all the three product terms, we will have all the variables A, B, and C, either in true form A, B, C or in complement form like A bar or C bar. So this is also canonical SOP form, function A, B, C, A bar, B, C bar, A, B bar, C. In case of non-canonical form, we can see that this is another function of A, B, C of three variables, but here we have A plus B dot C bar plus A dot B bar. Here the variable B and C is missing, here the variable A is missing, and here the variable C is missing. Okay? So sum of product form, that means logical OR operation. In case of logical OR operation, that means here we do the OR of the variables, then we take the product of those logical OR operations. This is called POS. So in POS form, the sum term is the logical OR operation of the different variables of the function. Variables can be in true form or in the complement form. Here defined sum terms are logically ANDed. Logically ANDed. Here defined sum terms are logically ANDed. Okay. So this one is a sum terms as A plus B bar plus C, A plus B bar. And then we are out this one or use the product form. So it can be also a non-canonical or canonical form, right? So again, in the non-canonical form, the variables will be missing. That means if it is a function of three variables, maybe one of or two functions are not present in the max term. So this is function of three variables of f1, a, b, c. Here we can see that we have a sum operation of a bar plus b dot a plus b bar plus c dot b plus c bar. So these are non-canonical POS form because here the variable c is missing. In this case, variable a is missing. So in this case also, this function to a, b, c, d, we have four variables. So all the four variables must be present in the output. But here we can see there is a missing term of missing variables of a and c. Here missing variables of c. Here missing variables b and d. On the other hand, this function f3 of two variables, and this is the output. We have a bar plus b dot a plus b bar plus dot a bar plus b bar. All the variables are present here. your side, all of you done? So each sum terms contains all the variables in the canonical POS form. Each sum term contains all the variables. So this is each sum term. Okay. So in this canonical form, we have three variables, and we can see. So we are talking about POS is still product of sum. So in this function of F4, we have three variables, and we also have all the three variables, right? In this case, we have four variables. Also, we have the four variables. So this is the canonical form, and this is the product form. Okay. In canonical SOP form, each product term is also called mean term. In canonical SOP, sum of product, right? Sum of product like AB plus B dot plus BC plus CA like this. In form, each product term is known as mean term. Each product term is known as mean term. It is also known as sum of mean term. Like this. This is a canonical SOP form. Again, what is the canonical SOP form? The canonical SOP form means all the variables will be present. All the variables will be present in each mean term. So this is function F1, A, B, C. We have three variables, and these are the mean terms A, B, C, A bar, B dot C bar, A, B bar, C bar. So each product term is known as the mean term. Each product term is known as the mean term. On the other hand, in case of canonical POS, product of sum, POS, each term is known as max term. Each sum term is known as max term. Here, A bar plus B plus C bar dot A, B bar plus C bar dot A plus B plus C. So each sum terms is known as max term. So sum terms are known as max term, product term known as mean term. In case of SOP, we will see the mean term. In case of POS, we will get max term. Okay. So what is this mean term? And it is the product term which consists of all the variables of the function either in true form or in complement form. This is the mean term, right? It's the product of the variables either in true form or in complement form. So for defined input, for example, if we have two variables, it will have, of course, four different combinations or four different of inputs, 0, 0, 0, 1, 1, 0, 1, 1. Accordingly, we will get these mean terms. So as the mean terms is a product term, so we need to find out the output will be high. So when the output will be high, so when you take the complement, that's why this 0, 0 for the mean term of 0, 0 is A bar, B bar, and this one for A bar, B, and this is for A, B bar, and this one is A. And each mean term can be given a number of corresponding number M0, M1, M2, M3. So mean term M is denoted in a small letter n, and the subscription 0, 1, 2, 3 is the position 0, 1, 2, 3. So if we have a function of n variables, then we should have 2 to the power n number of mean terms, right? If we have n variables, it will be a 2 to the power n number of mean terms. Okay. Then, so if we have the three variables, so if you have given the truth table of any logic circuit, how we can write this Boolean expression in terms of mean term? For example, the truth table is given, so we can easily write down from the truth table. You can also write down the Boolean expression using the mean terms, like this one. For example, it is a three variables function, A, B, C. So it will have 2 to the power 3 equals to 8 mean terms from 0 to 7. And the function is a truth table, but the function will be given which mean terms are high. Which mean terms are high. For example, in this truth table, we can see for four combination, this one, and certain combination. No, sorry, this is not that example. We'll go for the example in next slide. So this is the mean term we can explain from A bar, B bar, C bar to ABC, from M0 to M7. So since the mean terms are product terms, so its output is 1 only for the specific input combination. Okay. So, for example, here we have a function is given in a table. So in the table we can see this function is high, output is high for 4 different input combinations. This one, and this one. So we need to find out, it can be given in a truth table or it can be given in an algebraic form, like this one. So we can also find out the algebraic form here. So this function will be high when the midterm will be a bar, b bar, c bar. And this function will be high when it is a bar, b, c bar. And for this function to be high, it will be input a, b bar, c bar, and this one will be a, b, c. So this is the function f1 can be written in algebraic form, a bar, b bar, c bar plus a bar, b, c bar plus a, b bar, c bar plus a, b, c bar. So it's a SOP, right? Sum of product. And it is a canonical SOP because all the variables are present in every min terms, ABC, 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 either in true form or in complement form. So this is the canonical SOP form. We can represent this canonical SOP form according to their position also, M0, because this is ABC bar, so this means it is 0. So this is also, we can, ABC bar means we can put the value of A, so it is 0, 0, 0. It is 0, 1, 0. This is 1, 0, 0. This is 1, 1, 1. So 1, 1, 1 means 7, right? If you add the weight of the position, 4 plus 2 plus 1, 6, 7, then it is 1, 0, 0, that means 4. This is 1, 0, 1, that means 4 plus 1, 5. This is 0, 0, 0, that means 0. So M0, M2, M4, M7. This SOP can also be represented by this sign. It's a summation sign, means is the sum of product. And it is given by this is the decimal numbers. We can see here represent this 0 to 47. 0 to 47. So this is how from the truth table also we can find out the SOP. Canonical SOP. Not SOP actually, it's a canonical SOP. So that is the how. So function f2 is high only for 3 input combinations that I mentioned. So write down the min terms corresponding to those 3 input combinations. Then perform the logical OR operation of these min terms. This is the logical OR operations. Then sigma represents the summation of min terms, and decimal numbers are the subscript of the min terms. What is the max term? So max term is the corresponding to each input combination here. So max term will represent to the POS, product of sum, right? Product of sum. Previously it was sum of product. So each max term is the summation of all the variation. Now we need to do the addition, right? And logical addition, a plus b plus c or a plus b plus c plus d, right? So, and those sum terms are known as the max term. Each max term is the summation of all the variables because we are talking about the canonical POS. Canonical POS is supposed to be all the variables supposed to be there, present. Variable can be either in true form or in the complemented form depending on the value of the variables. And if the variable is 0, then it represents in the true form. So it is opposite. It will be opposite. In case of SOP, when the variable is 1, it was in the true form. It will become opposite now. Did I mention here this one? So if the variable is 0, then it is represented in the true form. Okay? So this is for 2 to the power n max terms. So if you have n input, the max terms will be 2 to the power n. So for 2 variables, 2 to the power 2, that means 4 different max terms. 0, 0, 0, 1, 1, 0, 1, 1. For 0, 0, the max term is a plus b, which can be denoted by capital M subscript 0, 0, 1, a plus b bar. So for a, it will be true form. For 1, it will be complement form. So this is the difference. Okay? This is the difference. For 1, 0, 1. So this is a plus b, this is a plus b bar, this is a bar plus b, that is a bar b bar. And represented by M0, M1, M2, M3. For the 3 variables input, so there will be 2 to the 3 equals to 8 max terms. From a plus b plus c to a bar plus b bar to c bar. Okay? and we can represent from M0 to M7. So again, as I mentioned, for the 0 it will be true form. For the 1 it will be complement form. So that means 0, 0, 0. So A plus B plus C. So it will be A plus B plus C bar. It will be A plus B bar plus C. It is A, B bar, C bar, A plus B bar plus C bar, A bar plus B plus C, A bar plus B plus C bar, A bar plus B bar plus C, A bar plus B bar plus C bar. Okay. So if a function can be given in a truth table or in the algebraic form. If the function is given in a truth table, then we need to find out for zeros also, right? Here they also shows us that we can do, at first we can take a complement of the POS form. That means the function is given this one, this function is given for three variables, A, B, C, function is 1, 0, 1, 0, 1, 0, 0, 1. And they ask us to find out the POS. So what we can do, at first we can take the complement of the function f1. If you take the complement of function f1, what will become? 1 will become 0, 0 will become 1, 1 will become 0, 0 will become 1, 1 transfer to 0, 0 will become 1, 0 to 1, 1 to 0. Then this is function f1, right? So if you take the now double derivative, so this is the represented. This is the representation of A bar, B bar, C. Which one is A bar, B bar, C? This one. Because this is 1, this is 1, this is 1. So in the SOP form, we take the mean terms. We take the mean terms. So this is SOP form. It becomes SOP form, right? These 4 ones. So this is the ones of our mean terms for A bar dot B bar dot C. This one for A bar B C. This one for A B bar C, and this one A B C bar. Then if you take the double complement here, so this double bar will become F1, and we can apply now De Morgan's theorem. If we apply this De Morgan's theorem, then we'll get from here to here ABC dot AB, sorry, A bar B bar C dot A bar B C dot A B bar C dot A B C bar. Then the whole bar, whole bar, whole bar. Because the sum product or it will become product. So this is the De Morgan's theorem. Still we have another bar, so we can do the De Morgan's theorem once again. We can get this De Morgan's theorem, so it will become A plus B plus C bar dot A plus B bar plus C bar dot A bar B plus B plus C bar dot A bar plus B bar plus C. So now this function f1 becomes this one. So you can see here now it is A plus B plus C bar. Which one? This one, right?
0, 1.
Which one? This one? A plus B plus C bar? This one.
0, 0, 1.
Right?
Yes.
0, 0, 1. Because now we are looking for the max term, output supposed to be 0. Right? Output supposed to be. In case of min term, the output of the whole system expression will be 1. Min term will be 1. In case of max term, it will be 0. So these are the zeros, 1, 2, 3, 4. So this 0, as I mentioned, when we have a 0, it will be a true form. When it is in 1, it will be in complement form. So this is A plus B plus C bar, this one. In this case, what we see, A, B bar, C bar, A plus B bar, C bar. In this case, A bar plus B plus C bar. And finally this one, A bar plus B bar plus C bar. Okay? So we can get this one like this. So it can be also mentioned like that. So from here we can know the positions. So this is 0, 0, 1. So this is M1. And this is 0, 1, 1. This is 3, M3. This is 1, 0, 1. That means 5. And this is 1, 1, 0. This is 6. And it is also denoted by pi. So this is the position 1, 3, 5, 6. So this is the canonical POS, canonical product of sum. So we have the canonical SOP and we have also canonical POS. So all the 4 combinations Here all the four combinations corresponding to max term M1, M2, M3, and 4. All the max term in this function F1 is equals to 0. Right? So POS is supposed to be 0. All the max term in this function F1 is equals to 0. So in POS form or product of max term, the function is equals to 0. In POS, the function will be equals to 0. In SOP, the function will be equals to 1. So directly from the truth table also, we don't need to do that. Directly from the truth table, that means we can find out this POS, right? Directly from the truth table, we can write the expression in POS form for the input combination that is given F1 equals to 0. So in this function, we have this one given. So this is will be the my POS. So A plus B plus C, A plus B plus C bar, A bar plus B bar plus C plus A bar plus B bar plus C bar. And then we'll take the product. Okay. So we can say that this main term is the complement of the max term. Right? The main term is actually a complement of the max term. So we can easily convert any canonical SOP form into the equivalent canonical POS form. Right? We can easily convert from SOP to POC. Of course, it's supposed to be canonical, as they are just complement of each other. So a function is given in canonical form, for example, this one. So if we take the complement of F1, then it contains all the midterms, right? If the canonical is given, function is given, and if you take the complement of F1, then it contains all the midterms, which function F1 is equals to 0. So if you take a complement, once again, we will get F1. So using the De Morgan's law, we just mentioned what we have done. So now take the complement of the midterms, it will give you the max term. So now we can say that the SOP contains the number that is not present in the POS form, or vice versa. It's simple. So SOP contains the number which is not present in the POS form. So without the truth table also, we can easily convert any canonical SOP form into the equivalent POS form. So that means if we have given this one, function F1 with the summation sign, we already understand that this is a min terms. So in this truth table, we have 3 variables, so it will be 8 min terms or 8 max terms, right? So already the min terms is given for function F1 is 0, 2, 4, 7. So what will be the POS? POS will be 1, 3, 5, 6. Okay. So as I mentioned, so if you have the 3 variables, it will be 8 min terms and 8 max terms. So if the function F2 is given for this capital letter M 0, 3, 4, 7, that means they are max POS, max terms. So we can also write in this form 0 through 4, 7. Okay. So I will start this conversion after I take a break for 5 minutes.
I'm not gonna lie, I don't really know.
Okay, that's what I
Yeah, it's
kind of asked.
really tough, yeah. This last one especially, like, I can't even walk myself through it.
Really?
To be honest, yeah. The previous ones I do have things come here, but 2 and 5 still.
Do you have any suggestions? I didn't do a lot of this in the last class. Yeah, more of this. Yeah, you did. You did, what's his first class? Very beginning.
Yeah, I haven't, honestly, I haven't.
Okay.
So, yeah, that's so he hasn't, he didn't even come to this last.
No, he really didn't. When I get to this point, he had all the beginning of it, especially not being able to work through
Yeah, because I barely remember this, but we haven't, you haven't.
What a dumb.
I'm gonna tell him I'm probably with most of this, just because he won't believe that I actually know it. Yeah, it's tricky.
Is it, are you learning through YouTube again, or are you?
He suggested going through the last year's textbook.
Okay.
Yeah, for some of the stuff, but honestly, I think not like the textbook. Yeah, I might help him with some of the stuff.
Okay, I just wondered, because I looked at it, and I was kind of lost, I should take it on visual studio, the cross is getting in the way right now, so. Yeah, we're in season right now, starting it up, I'm like, I don't go to Friday classes, because I have practice, or he records, so I'll watch it. Some of it makes sense, and then sometimes he's like.
No,
But it's very slowly, I'm like, it's hard to watch sometimes.
It's that too, it doesn't fully cover the stuff that's like actually.
Exactly, yeah.
You know, like he'll cover the stuff that like you can kind of learn on your own, but when it comes to like this, it's like really easy.
Okay, yeah, thank you. I just,
I wish I could help.
no, it's all good. It's all good. I'm Hayden. Nice to meet you.
Me and my friends are in controls.
Okay, yeah, that's what I ended up getting into.
Yeah, so if it's anything like that, he's nice.
As long as you work through it or try to work through it, I guess. Okay, perfect.
So at least, yeah, show him.
We'll see. Thank
Really
you.
trying, yeah.
Thank you. You too.
Thank you. So already saw that we have a canonical SOP and canonical QS form. So that means in a canonical SOP and QS form, in case of min terms or in case of max terms, all the variables are supposed to be here in each min terms or in each sum terms, right? But if any of the min terms or any of the max terms have missing variables, then we call it non-canonical SOP form. But we need to convert it, sometimes we need to make a conversion from this non-canonical to canonical SOP form. Okay. So these are the non-canonical QS and the non-canonical SOP form. That means variables are missing here. So we need to convert it. Okay. So first understand the SOP form, that means sum of product form. This non-canonical to canonical form, and take a function of two variables. So this is the function of two variables and this is the output, A plus B. So here we have, we can see that each min terms have a missing variables. In the first term, the missing variables is B. In the second min terms, the missing variables is A. So we need to change it. So we need to make it a canonical form. So how we can do that? So at first, these are the steps. At first, we need to include the missing terms. Include the missing terms. Then expand the expansion, and then remove any redundant terms after the expansion. So these are the three steps. At first, add the missing terms or include the missing terms. It's better include. If I say that add, then it will become QS. So include the missing terms, expand the expansion, remove any redundant terms. So that means if you look at here, in the first term, if this is a function of A, B, C of three variables, and we have three min terms, but here we have missing terms of B and C. Here we have a missing terms of BC. Sorry, in the BC we have missing terms of A, and here we have missing terms of C. So we need to include those things. How we can include these things? We can include, in case of missing terms, for the first one it is A. So we have a missing of B and C. We can add those things, A dot B plus B bar times C plus C bar. Because from the Boolean rules, we already know B plus B bar equals to 1. B bar B plus equals to 1. C bar C plus equals to 1. So it remains A. But we can add these things, right? Still it is A. So no problem. Then we need to expand this one. So how we can do expand? AB plus AB bar, then again C plus C bar. Then again expanding ABC plus ABC bar plus AB bar C plus A B bar C bar. If we have any redundant, we can remove those parts. Do we have any redundant here? ABC bar, no redundant variables, right? So now from here we have four different min terms. Four different min terms, and each min terms have all the variables ABC, ABC bar, AB bar C, AB bar C bar, either in true form or in complement form. So we already expand the A already. In the second one, we have a missing term of A. So you simply, if it's missing term of A, it is B dot C, right? B dot C, we have to add A. So we got A plus A bar. A plus A bar, then expand this equation, A, B, C plus A bar, B, C. So you get two min terms. And for the third one, we have a missing terms of C, right? Missing variable is C. So we have A and B, right? A dot B
into C plus
into C plus C bar. Then extend it ABC plus AB C bar. So we have here 1, 2, 3, 4, 5, 6, 7, 8. Now to get the overall expression, can you see this? So to get the overall expression, we need to find out, is there any redundant? Is there any redundant min term? So we can see there are redundant ABC, ABC, and ABC. We will take only one ABC. We will take only one ABC. Then it is ABC bar. Do we have any ABC bar? ABC bar? We don't have, I think.
and second one, sir.
We have
Yeah, second one there.
ABC bar.
Second one at the
ABC
top.
bar. So we have another ABC bar, right? So we don't need to take this one. Then what else we have? So A bar BC. A bar BC we have
Only one.
only one. A bar BC. Then ABC already given. ABC bar.
ABC bar.
A B C bar. A B bar C. A B bar C plus A B bar C bar. So we can convert it to non-canonical to canonical. Still, it's the same expression of the original one. So this is how we can convert from non-canonical to canonical SP form, right? So this one. So here we can also find out the position, right? So here, did I miss any number? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here, this is as a min term. This is the min term, right? SOP. So this is 1, 1, 1. This is 0, 1, 1. This is 1, 1, 0. This one is 1, 0, 1. This one is 1, 0, 0. So this 1, 1 means 7. So M7. This is 3, right? 0, 1, 1 means 3. M3. This is 4 plus 2, 6. M6. This one is 5. 4 plus 1, 5. M5. And this one is 4. So we can write down the function f. If I write down the function here,
F1.
f1 is to sigma. So 3, 4, 5, 6, 7. From here also we can also find the QS, right? Now, so for function f1, QoS will be what? 0, 1, 2. Because as I mentioned that if we have a 3 variables, then it will be have 8 different combinations, right? So it can be 8 max term or 8 min terms. So if the min terms is given, the other will be the missing terms will be the POS. So here in this equation, in this function, these are the min terms we have. M3, M4, M5, and 6 and 7. So if 3, 4, 5, 6, 7 are the min terms, 0, 1, 2 will be the POS. Next term, POS. Okay. So this one, again, so this is the function of 3 variables, but here we have a missing. This is the function AB plus C. Right here we have a missing of C. Here we have a missing of A and B. Right? So if the missing comes, we need to include those things, C plus C bar. Here we include A plus A bar and B plus B bar. Then we need to expand this one. So once we expand, we got this one. So we'll get this F3 equals to 1, 3, 5, 6, 7. 1, 3, 5, 6, 7. Okay. But this is the very long technique. There is a shortcut method to find or to convert from this non-canonical to canonical. A very shortcut method, very easy one. So what we need to do in a shortcut method, we need to put X in case of the missing term, in the place of missing term. In place of missing variable, put X. in the min term, if variables are in two form, then its value will be 1, right? The min terms, we are always looking for high value, min terms. In the min terms, if the value is in two form, it will be equals to 1. And if the min terms in complemented form, the value will be 0. Now put x equals to 1 and x equals to 0. So very simple one. If we take the previous example again, so which is function f of 2, function f2 of 3 variables, right? A, B and C. It is equals to A dot B plus C. So for the first midterms, the missing variable is C, right? So in terms of missing, we put x plus, here we have a C, but we have missing variables of A and B. So x, and C. The second step is, if the midterms is in true form, we can set 1. So both are true forms, we can set 1. Here also, midterms are in true form, we will set 1. Now put the value of x. So x value can be either 0 or can be 1, right? So if there are, so 1, 1, 0, 1, 1, 1. This is the possibility. Here we have two variables unknown, so it can be 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1. So this is the midterm. So what is 1, 1, 0? 4 plus 2, 6. So this is M6. What is 1 plus 1? 1, 1, 1. 4 plus 2 plus 1, 7. M7. So from here we get these two midterms. Here we will have 0, 0, 1. So this is M1, right? This one 0, 1, 1. M3, 2 plus 1. This is 1, 0, 1. 4 plus 1. M5. And this is 1, 1, 1, M7. So if you look at here, we have one redundant, M7. So the function F1 will be, what we have? 1, 3, 5, 6, 7. 1, 3, 5, 6, 7. So this is the easiest way. This is known as shorthand method or shortcut method to convert from non-canonical to canonical form. Okay? Find this one. Try this one. This one. So, what are the missing term here? A, B bar, we don't have C, we don't have D.
I have a
Here,
question.
We have missing term A, B, C bar, D.
We have a B bar. We don't have B, so it's the same.
Yeah. So, as I mentioned, it can be a true form or in any complement form. It can be there. So if it is in true form, you need to set 1. If it is in complement form, you need to set value 0 in case of meter.
So it's 1 for midterms and 0 for finding the maximums.
In case of maximum, it is the opposite. So now we are talking about the SOP. So this is the midterm. So midterm, the true value, for the true value, it will be value is 1. And for the complement, it is value 0. Okay. So now we need to put the value. So this is 1, 0, XX, XX, 0, 1, right? So now we have two variables. So 0, 0, 0, 1, 1, 0, 1, 1, right? So we have 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, sorry, 1, 0,
1 1.
1. Plus. We have 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1. All of you have the same answer?
Yes, sir.
So then we just need to mention what is this one? M, 8, position 8. This is 8 plus 1,
9,
M, 9.
10.
This is 8 plus 2, M, 10. This is 8
11.
plus 1, M, 11.
11.
Here we have
M1.
M1, then 8 plus 1,
5.
M5,
9.
then M9,
13.
and 38 plus 4 plus 1. So we can write down function 3, so this summation of. So do you have any redundant? I think we have one redundant, right? M9.
M9.
We have one redundant.
1.
So we can start from M1,
5.
M5, or just one,
Yes, sir. 1.
1,
5.
5,
8.
8,
9.
9,
10.
10,
11. 13.
11, 13. So, and for the
P was
US,
5.
it will be 0, 2, 3, 4,
6, 7.
6, 7,
12, 14, 15.
12, 14. So, we can easily find out canonical, SOP, and US form.
We don't have 10.
We don't miss the 10, we have 10 here.
We will not have it. It's not one M10.
It is not 10,
It's 10.
And the last digit is not one, right? Why will we consider it?
0, 0, 0, 1, 1, 0, 1, 1. What is the problem?
I mean, if D is one, we consider it as like midterm, right?
Here. So in this, you cannot take from here to here. We need to take the individual one. We are trying to get the non-canonical canonical. That means each and every midterm is supposed to have all the variables, right? A, B, C, D, either in true form, either in complement form. Here we have two midterms, two separate midterms. Here missing is C and D. Here missing is A and B. So it's not meaning that here we have A, so we can use A here. So here A, B bar. So for the true, it is 1. For the complement, it is 0. So we have 1, 0. So it is 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Then we have missing C and D, XX. So two variables, two, four options. 0, 0, 0, 1, 1, 0, 1, 1.
If LSB is one, we consider it as midterm, right? If the leasing and
What do you mean by n exponents?
if the last digit is one, and we consider as high as we can.
So here, you are talking about this one, this one is fine. You are talking about this one, can you say anything here?
No, I mean, might
So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So 0, 0, 0, 1, 1, 0, 1, 1. So this 0, 0, 0, 1 is M1, this 1, 0, 1, M5, this 1, 0, 0, 1, M9, this 1, 1, 0, 1, M13.
Why are we considering 10?
For A. Here, 1, 0, 1, 0.
Yeah. So why are we considering it as minimum? How we are selecting these as minimum based on the LSP between?
Because in the SOP, the product term is known as the mean term.
Yeah.
This is SOP, sum of product, right? Sum of, this is product, this is sum. In this sum of product term, this product term is, in fact, it's a mean term. This is mean term. And this mean term is non-canonical
Yes.
because all the variables are not present here. We are just trying to convert it to canonical so that we can make it counter. Maybe I'm not getting your question. Can anyone help me?
I mean, if the function is high, we will consider it as like we will write the expression. Here, in the 10th, the function is not high.
Okay, I will talk in here. Is anyone having any question to this one?
No.
Okay, maybe I can come, we can talk later on this one. Okay. So POS. In case of POS means it's a product of sum. Product of sum. That means we have a sum, then we need to give the product one. So if sum term does not contain all the variables of the function, this is a function of 3 variables and this is the output a plus b dot a bar plus c. So we have a missing variables here, also we have a missing variables here. In the first max term or the first all terms, we have a max term or the odd terms, we have a missing variables of c, and here we have a missing variables of b. So we need to add or we need to include. So this is the way we can include here. In the SOP, non-canonical SOP, we include by c plus c bar because it will give me 1, and whenever we treat the product, it will give the same value. Here we need to just do the opposite one. So the first next term is a plus b and the missing term is c. So we can just do like this, a plus b plus c dot c bar, because we know c plus c bar is 0. So still it is a plus b. So we don't have any issue. Then we need to use the distributive law. We need to use the distributive law. What is the distributive law? For example, if we consider this one as x, this one as x, so it is x plus,
C.
we can say that this is x plus c dot
X.
c bar, right? So if we apply this distributive law, we can write this one as x plus c dot
X plus
x
C.
plus, sorry, capital X plus c bar.
C.
Now if you replace this x by a plus b,
Plus C.
a plus b plus c. So from here to here, this is the same. Now this is the max term and this is a canonical form because all the variables are now available here. A plus b plus c, a plus b plus c bar. It can be either true form or in the complement form. But variable must be there. To make it a canonical POS, all the variables of the function must be there. This is the rule. The variable can be either true form or in the complement form. Okay? So next what we have? A bar
Plus
C. So A bar plus C, the missing term is which one? Plus B
B
dot
dot B bar.
B bar. So again here we can write down like this, A bar plus C plus B dot A bar plus C plus
B
B
bar.
bar. So this one, this term, the second next term will give you two next terms, and the first one will give you this one. If I just remove all these things, it is just this one. So now we have to find out if there are any redundant. If we have any redundant, we can use only one. Otherwise, we can add all these others. So these are the four terms are the max terms. So this is for A bar C, which is A bar C plus B, A bar C plus C plus B bar. And for the A plus B, it is A bar A plus B plus C into A plus B plus C bar. Each term contains all the variables of the function. Output is the product of all these max terms. So output will be the product, right? Because it is a POS, product of sum, product of sum. So output is the product of all these max terms. So in case of SOP, we do the what we do? We do I forgot. We do what the name? Just let me check. We do the product and variable expand. In case of SOP, to get the SOP, we do the expansion, and in case of POS, we do the distribution. Okay, we use the distribution. Okay. What about this one? Look at here. So we have A plus B and A bar C. So here, this one is the previous one. Yeah, this is the previous one. So from here, so in this case now the complement will be 1 and the true form will be 0. True form will be 0, complement will be 1. So here it is 1, right? 1, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 1. So that's why it is 0, 1, 4, 6. Right? Again, this is the little tricky. Sometimes we get confused with, because we have SOP and POS in the min term and the max term. So in the just try to remember one, other will be the opposite. So in the min term, we'll take the product and output will be high. So we are looking for the high. Because all the inputs should be, it's a product, right? 1 into 1 into 1 will be 0. If any input is 0, it will be 0. Okay. So in the min terms, we will try to give the true form the value 1 and the complement to value 0. On the next term, we give the true form value 0 and the complement to 1. So if it is, this is the POS 0, 1, 4, 6, as this is a 3 variables, we have 8 min term and 8 max term. The rest missing terms will be the SOP, canonical SOP. So canonical SOP will be 2, 3, 5, and 7. Right? So again, we can use the shortcut method. Same way. So we have to give the missing to the X, and then we need to set the true form to 0 and the complement to 1. Then we can get this value. For example, the same example, A plus B. So A plus B dot A bar plus C, right? This is my function. So we have missing function is B, right? Here we have missing function C, sorry, here we have missing function B. So we can write down A plus B plus X. Here we can write down A bar plus X plus C. So it is a true form 0. X can be 0 or 1.
0 plus 1.
Right?
1.
So 1 is a complement. So it will be 1. Then 0,
plus
this is
0.
true form 0. Again, x value can be 0 or 1.
1 plus 1 plus 0.
This one. So there is right one. Now we need to find out. So 0, 0, 0. This is a POS. So A plus B plus C. So M0, right?
M0.
This is 0, 0, 1.
M1.
This is 1, 0, 0.
M4.
And this is
M6.
1, 1, 0.
M6.
And 6. So this function will be 5, 0, 1, 4, 6. 0, 1, 4, 6. So for the canonical SOP, 0, 1, 2, 3, 5, 7. So we can easily use it. Actually, we use the shortcut method, right? So by using the shortcut method, we can get the canonical SOP and POS. So this is how we can use M0 for 10, 11. This is for another one, A, B, C, D. So we have a missing B here. We have a missing A and B here.
D.
And we have a missing D here. So A, C, D, so X is missing here. So this is in two form, 0x, 0, 0. X can be value of 0 and 1. So 0, 0, 0, 0, 0, 1, 0, 0. 0, 0, 0, 0 means M0, 0, 1, 0 means 4, so M4. For this one, we have a missing D, right? It is a complement, it will be 1. It is a two form, it will be 0.
0.
So 1, 0, 1x, 1, 0, 1x. So x value can be either 0 or 1. So 1, 0, 1, 0, 1, 0, 1, 1.
M10, M10.
So 1, 1, 0, 1, 0 means 8 plus 2, M10. It is 8 plus 2 plus 1, M11. Remaining is BC. So this is the second term, B plus C. Here we are missing A and D. So A and D is missing, and they are complement. So x plus 1 plus 1 plus x. So the value of x can be either 0, 0. So they just use this one, and 6 and 7. So if you take all the value, if any redundant, we just choose 1, and then we can write down the function like this way. And the rest will be the canonical SOP. So this is all about the SOP and POS. Now I'll move to the next. I didn't upload, I'll upload later. Just carry on. The K-man. So K-map is the technique to minimize the Boolean expression. We need to always try to minimize the Boolean expression, right? So that we can reduce the circuitry. If we can reduce the circuitry, it will be actually important for us. Why? Because we need to reduce the space, we need to reduce the power consumption. So we need to reduce the cost. So usually we do that by using the Boolean's laws and the Boolean's rules, right? But sometimes it's not possible. But if the number of variables increases, the Boolean algebra will become very large. And sometimes it's not possible that whether it is the min term, the minimized or not. So there is a technique known as K-map, kind of map or K-map, which will give you the true result that you can easily, by mapping the numbers, min terms in the map, we can easily find out the minimum expression of the Boolean. So here we record, for example, here we record 3 gates for this expression and 1 OR gate. Maybe by using the Boolean's laws and rules, we just minimize some things. Now we require 2 gates and 1 OR gate. But it's very complex. So that's why we need to use the K-map. So for example, if you have 2 variables, then 4 combinations, and these are the min terms, right? Because as you already mentioned, we need to have a high one. So that's why it's A bar, B bar, this is A bar B, A, B bar, and AB. And this is the min terms M0, M1, M2, and M3. So to get the K-map, at first we need to draw the map. So we have to construct the map. To construct the map, we have the rows and columns. So digit beside each row is possible values for A, because we are talking about only 2 variables, and digit above each column is possible values of B. Combination of A, B is represented by each cell of the K-map. That means each cell of the map represents a particular minterm, right? Product, particular minterm. This one, for example, 0, 0. So 0, 0, this is A bar, B bar. This is 0, 1. So this is 0, 1. It will be A bar, B. This one 1, 0. This is 1, 0. It will be A, B bar, and this is A, B. So at first we need to construct the K-map. Then we need to place those minterms in the K-map. This means the numbers on the top of each, so this is for 3 variables same. So in the 3 variables there will be 2 to the power 3, 8 minterms. So there will be 8 cells. So here in this digit, on the above of the column, it will be B and C variables. On the left side of the row, it will be the A variables. Okay. And each cell represents each minterm and in K-map. And the important thing is that in the K-map, the numbering is done by gray code. This is the important thing. The numbering is done by gray code. That means in between two adjacent cells, only one bit will change. Only one bit will change. That's why when you shift from 0 to 1 and 1 to 2, we are not shifting from 1 to 2, rather we are shifting from 1 to 3. Because from here 0 to 0, 0, 0, 1, only one bit is changing. But if you want to move from 1 to 2, this 0 will become 1 and this 1 becomes 0. So we are not doing that. We are doing from 0, 1 to 1, 1. So that means 0, 1, 2, 3. Because here only one bit is changing the position of B. So adjacent cell can be either side by side or up and down, even in the corner, even on the edges. All are known as adjacent cells. So here we use the gray code. Only one bit is changing between each pair of adjacent cells at a time. Okay. So that's why I show you just one bit changing at a time. Corner cells are also known as adjacent cells. For example, this one and this one. Because here, this is 1, 0, 0, and this one is 1, 1, 0. And you can see here only one bit is changing. So the bit of B. A is 1 here, A is 1. Because in entire row, A is 1. And in this column, B, C is 0, 0 and 1, 0. So C remains constant. Only one bit B changes from 0 to 1. So they follow the gray code. To place the minterms, we need to follow the gray code. So that means 0, 1, 2, 3, 4, 5, 6, 7, like this. So this is called mapping, how to map the Boolean expression. So this is this SOP form, and the function can be given in this manner or function can be given in the algebraic form. Then you need to decide. So if the function is given like this one, so this is A bar, B bar, so A bar, B bar means this one. This is A bar, B, so this one, and this is AB, and this one. So 0, 1, and 3, 0, 1, and 3. So the first we need to construct the map, then we need to put the map the expression in the K-map. Then we need to make a group of ones. Make a group of ones. So make a group of ones will be in the order of 2. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, like this, in the order of 2. Make up group ones. And we'll try to make the groups take as many of 1 as possible. So if we can take number of ones, 4 number of ones, we should take 4 number of ones. So we cannot make a group of 3 like this. We cannot make a group of like any other shape rather than the square or the rectangle shape. Either rectangle or the square shape. Okay. So during the grouping, we should make sure all the ones, and another important thing, we should make sure that all the ones are included. All the ones are included. So this one is the function. So we have a group of 1, 2 ones here. So whenever we have a group of 2 ones here, then a variable remain is unchanged here. If the variable is unchanged, we'll keep it. If any of the variable is changed, we'll discard it. Okay, if any of the variable is changed, to shift from one minterm to another minterm, because we have 2 minterms here, if any of the variables change, we discard that variables. If the variables remain, we'll use that variable.
It's like common variable for both minterms.
Yeah. And next thing is, if the variable is in 0, we'll take the complement. If the variable value is 1, we'll take the true value. That's it. So here, so variable A remain unchanged throughout the group. So you can see this is the group 0 unchanged, and here B is changing from 0 to 1. So we'll discard the B, we'll keep the A. As A equals to 0, it will become A bar. On the other hand, here A is changing from 0 to 1, but throughout the column B is remain 1. So as B equals to 1, we'll take the B equals to 1. So this group represents B. So from here we can find that it is A bar plus B. So this is how we can do the K method. So if it is only 1, 1, like this one, we need to choose different group. So the expression will be for this one A bar, B bar plus A, B. For this one is 2 again. If we have the for all 4 ones, the function will be 1. Okay. Just 2 minutes. So minimization of 3 variables. So if we have 3 variables, then we can put this 0, 1, 5. At first, we need to put the min-terms position 1 for the variables they given as a function. The function is given 0, 1, 5. That means, and the min-term position 0, 1, and 5. In 0 position, we put 1. In 1 position, we put 1. And in 2 position, we put 1. So we left the min-terms in the K map. Then we'll make a group of ones. So here we can cover, to cover this one, we can take one group. To cover this one, we need to take another group here. So we have 2 groups. For the first group, we can see A is unchangeable and B is also not changing, but C is changing, so we'll discard the C. So the function, the expression for the first group is A bar, B bar. A bar, B bar, because A equals to 0, B equals to 0. For the second group, we can see A is changing from 0 to 1, so A will discard. B and C is remaining 0, 1. B equals to 0, C equals to 1. So the expression for the second group will be B bar C. Then we take the sum, SOP, sum of product. We already get our product, now we need to OR. So the expression for this function will be A bar B bar plus B C. Sorry, A bar B bar plus B bar C. So this is how we will continue that from K map in the next week. Thank you.